Lithium batteries currently exist in almost all portable electronic devices, including phones, tablets, laptops, headphones, power banks, watches, portable media players, e-readers, e-cigarettes, and smart bags. Crew members are also carrying electronic flight bags and manuals and point-of-service devices in addition to their portable devices. Lithium batteries are capable of overheating, leading to a process called thermal runaway, which can cause the sudden release of the contents of the battery as heavy smoke, flammable gases, flames, or in some cases, the battery can explode. Once one cell in a battery pack goes into thermal runaway, it produces enough heat to cause adjacent cells to go into thermal runaway. The resulting fire can flare repeatedly as each cell ruptures and releases its contents. Here, for example, is a 5-cell battery in which the first cell experiences thermal runaway and burns out. But the battery isn't finished burning. 2 or 3 minutes later, the heat propagated from the first cell causes the adjacent cell to flare up. This process repeats every 2 or 3 minutes until all 5 cells are consumed. In this clip, you see a laptop on the left, a tablet in the middle, and a mobile phone on the right. This video demonstrates the difference in the reactions of the 3 devices with 3 different batteries. When portable electronic devices overheat in thermal runaway, there is typically a prolonged and larger reaction in a larger device, like a laptop, and a shorter, less violent reaction in a smaller device, like a mobile phone. Larger batteries, like those in laptops, may have more cells, which is why there's more opportunity for propagation, meaning the fire could last longer. Notice how the tablet and mobile phone have finished flaming, while the laptop on the left starts another thermal runaway, and flames erupt again as the cells propagate. Depending on how the lithium battery in the device is constructed, it may create more or less smoke or flames. In general, the larger the device is, the larger the battery, and the greater the hazard. Some of the first warning signs of an electronic device overheating and heading towards thermal runaway are any of the following: slight bulging, a discoloration of the screen, an unusual odor or unusually hot to the touch. There are basic lithium battery firefighting principles that always apply. First, immediate aggressive action is key. Second, the onboard fire extinguisher should be used to remove any flames. Finally, the third key principle is cooling. In most situations, the nature of battery fires requires immediate and aggressive action with the use of a fire extinguisher for flames, then dousing the device with liquid prior to donning personal protective equipment, PPE. Quick action may prevent escalation into an out-of-control battery fire or explosion. While the first person immediately responds to the incident, a second person can take over once they have donned their protective equipment, such as a smoke hood. Cooling can be accomplished by dousing the device with water or other non-alcoholic liquids, such as beverages. Cooling should continue until the device has reached cabin temperature again. This may take a few seconds or a few minutes, partially depending on how well the liquid or non-alcoholic beverage is applied. When in doubt, apply extra. The purpose of using the liquid is to cool the batteries. To be more effective, direct the liquid into available openings in the device so that the liquid can reach internally to the batteries. This will end the event sooner and decrease the likelihood of propagation. Cooling is especially important in larger devices, where you are trying to prevent the thermal runaway from propagating to the rest of the device or surrounding area. If the flames are not extinguished or the device is not properly cooled, flames and fire could continue to spread. This may lead to a catastrophic event or dense accumulation of smoke in the aircraft. Once the hazard is eliminated, the aircraft ventilation system will cause the smoke to dissipate. Passenger oxygen masks do not filter the cabin air and therefore should not be deployed in response to smoke in the cabin. Instead, moist paper towels may be used in a smoke-filled environment. There are several potential hazards that should be taken into consideration when there is an overheated battery in the cabin. A battery fire is intensified when aircraft oxygen gets involved in the fire. This scenario can quickly make a small battery fire into an uncontrolled event. Overheated PEDs that are still plugged in should be disconnected from their power source. A device that is overheating and being removed from the flight deck can become a fire hazard in the cabin. Lithium batteries are commonly used to power aircraft equipment in the cabin, such as portable ELTs, inflatable seat belts, emergency lighting, and AEDs. Be aware that because of the location of some of these devices, the firefighting process may require more effort to accomplish and may require more liquid for cooling. Devices in a bag under the seat may require careful removal of the bag to the aisle to address the overheating device. Caution should be taken when handling, opening, or moving a bag because the introduction of oxygen could lead to an unexpected fire. When a device is overheating in a seat back pocket, it may be more difficult to cool the batteries because of the device's orientation and the angle of the seat. There is also a risk of fire from a portable electronic device being inadvertently crushed inside an adjustable seat. If a passenger advises that they have lost their device in the seat, make sure the seat is not operated until the device can be located. If it is known or suspected that the device has been crushed, firefighting and protective equipment should be retrieved prior to attempting to retrieve the item. If the device cannot be found, the passenger should be moved to another seat. Monitor their original seat for any signs of fire or smoke. Upon arrival, seek the assistance of engineering staff to retrieve the device. When opening an overhead bin where a PED is overheating, surrounding bags may need to be removed to access the overheated device with fire extinguishers and liquid. Once the device has cooled sufficiently, the safest place for it to be stored is completely submerged in liquid. Battery technology and the hazards associated with overheated batteries is constantly evolving. Being aware of the potential hazards of overheated electronic devices and the most effective techniques to mitigate them is important for ongoing operational safety. Operators are encouraged to incorporate these principles into their training programs and procedures.